Example number 1. Simplify each expression. Alright, so the tricky bit here is we need to consider our non-permissible values. That's really the only tricky bit. First you factor, then you deal with the non-permissible values, and then you cancel. Same thing as we kind of did yesterday. The only thing is that we have an operation here instead of just being given an expression. Remember, an expression is something without an equal sign, just like this, right? There's no equal sign. It's not equated to something. We're going to say that this is equal to something, but in and of itself, this is just an expression. So first we need to factor, but we're just having a monomial over top of a monomial. Okay, there's only one term. So what we don't need to worry about factoring. What we do need to worry about here is the non-permissible values. The denominator can never equal 0. A can never equal 0. Do we care about B? No, because the numerator can absolutely be 0. It's just that denominator, we get that error in our calculator. Alright, so now I'm going to go in and cancel where I can. 3 goes into itself once. 3 goes into 9 3 times. Here's the tricky bit. A squared. So this just gets down to 1. So then when we multiply this together, we get 2 times b squared. I'm not going to use that. So we get 2b squared over 3 times 5 times a. 15a. Done. That's it. When we're multiplying, oh sorry, is that some, yeah, okay. In the next video I'm going to get to dividing. There's an extra little tricky bit, but we don't have to worry about that right now. First things first, factor. Guess what? It's all factored already. There's nothing that we can do to make it more simple. So this is a perfect opportunity for us to see where these denominators equal 0. Non-permissible values. With this one, x cannot equal 0 because if you go 3 times 0, the whole denominator equals 0. So x cannot equal 0. This one, x cannot equal 0, but we've already written it down, so we don't have to say x can't equal 0 and x can't equal 0. No, you just say it once. This one, x can't equal what? Please don't say positive 2. Please don't say positive 2. You have to think about what number will bring this bracket to 0. Oh, negative 2 plus 2 will make that 0. So x cannot equal negative 2. Now, if I were being a really huge stickler on form, which I can be sometimes, I want to write these in ascending order. So I know that my two numbers are negative 2 and 0. So I'm going to say negative 2 is the smaller one, and then 0 is the bigger number. Isn't it kind of weird that 0 is the bigger number? It's a pretty small number, actually. But it is definitely bigger than negative 2. Now what I want to do is I want to go in and cancel where I can. Look at this. We're going to just clean up this thing. X plus 2. What some people are going to want to do is they're going to want to take that 2 and cancel out with here. Don't do it. Just don't do it. Okay, you can't do that. If you cancel out an x plus 2, you have to cancel out another bracketed x plus 2 up top. It has nothing to do with this. This is a term, just like this is a term. Okay? Where else can I cancel? Can I cancel anything out with this x minus 4? No, can't do anything there. So I have 2 goes into itself once, 2 goes into 8 4 times. Look at this, folks. This x cancels out with one of the x's, okay? So it becomes x on top, but look, we have another x on the bottom here. So this whole thing actually turns to 1. So this is where it gets a little messy, and we need to remember what we actually have. This is a 1, this is a 1, this is a 1. So our numerator is just actually going to be 5x minus 4. What do we have on the bottom? 3 times 4 These guys get all canceled too. So all we have is 12. When we look at it and we're like, yeah, that's all we got. There are no common factors actually. So we can't make it any smaller. So this is our final answer.